Alright, Rob here. I just want to throw up this video real quick to help some people out if they were trying to get started with digital I/O. This is a quick program to test out my new PowerFet booster packs that came in, and it's just exercises of basic digital I/O on the LED driving pins and the power MOSFET and the LEDs on the launchpad. So it's pretty simple. So we'll get started. At the end of the video I'll show you what it looks like on a scope, just so we know that all the timing's right and it's doing what we expected it to do. So start off with your header file, include the header file for your chip. I'm using the 2553, so I include that. Shut off your watchdog timer. Configure your clock in this section, and I just did this real quick. This is the calibration constant. Well, both of these are calibration constants from the header file up here, and so I just set the digital controlled oscillator, the DCO, at 8 megahertz, and that's going to source my two clocks. So we configure the main clock first, and in this line we just configure the main clock to be sourced from DCO. We don't divide that down by anything, so it's 8 megahertz. That's your instruction cycle clock. And then the next clock is a sub-main clock, which I use in this program and most programs to drive my peripherals, and we slowed that down a little bit. You'll see why when we get down there for timing. But that's configured to be sourced from the DCO as well, and the only difference here is that we're dividing that by 8. So that gives us a sub-main clock of 1 megahertz. Next, the push button. This is the only kind of confusing thing. If you haven't used the button on the launch pad and you're not familiar with pull-ups, then we'll go over this real quick. So I guess the first thing is to understand how the button works. So if you look at the schematics from the user's manual, you'll see P1.3 is switch 2 right here, and that's what we're configured. We don't use it in this program, but just in case you're interested, it's when it's pushed, it connects your pin to ground, so your pin's going to interrupt on a falling edge, and the other side of the button is connected to the actual pin on the MSP. And the problem with this is that if the button is not pushed, that's open, and your pin is floating. So your pin's going to have all kinds of values between 0 and 3.3 or off and on. So if this isn't pulled up in hardware, which it isn't, you need to pull it up in software, which is kind of hardware in the chip. But to do this in software, it's pretty simple. You enable weak pull-ups for the pin. Each pin has internal pull-up resistors. Basically, you can configure to pull that pin high in a situation like this so it doesn't float. So what you want to do is enable pull-ups for the push button on the port you're going to use. Clear the output bit. Just good practice. And since it's an input, set the direction as an input, and enable the pin to interrupt on a falling edge with the P1 IES register. Clear the interrupt flag and enable interrupts for bit 3 on port 1. So that's pretty simple. All you're doing is enabling that pull-up resistor so that your pin doesn't float, and it's pulled high until you push the button in, then it's driven to ground. The next part is the pin configuration, and all we do with these pins is configure them to digital I/O, make them outputs, and we toggle them with a capture compare 0 interrupt service routine. So here I configure P1.5, so that's an LED on the, that's one of the LEDs on the PowerFet booster pack, and then these are the other 3 LEDs on the PowerFet booster pack. So all 4 LEDs are set here as outputs, and their output bits are cleared, so they're off initially. These are the launchpad LEDs. I just made them blink as well. And then we've got the PowerFet outputs. I also want them to turn on and off at the same frequency, and we can check and make sure all this stuff matches up. So this is the same as above. Set your direction for that pin to be an output and clear that output bit. Set the direction of the pin to be an output, clear the output bit, and last thing we configure is timer 0. We're only using CCR 0, capture compare register 0. So here's where the sub-main clock comes in. We configure the register, or configure the timer to run in continuous mode, which means it's going to count from 0 to FFFF constantly, and it's just going to overflow and start over and go in a loop as long as the chip's on. So we'll have to append our count value, which we'll talk about in a sec, in the service routine. And then you just configure the capture compare register. And so we're using CCR0. We enable an interrupt for that. We clear the interrupt flag and we set the CCR0 value to 5,000. So this gives us an interrupt of about 25 times a second, 25 hertz, or every 40 milliseconds. And last but not least, remember to put the chip, well, really just remember to enable global interrupts. So your interrupt routines will get triggered, and you can also put the chip in a low power mode here, so it goes to sleep. So here's the interrupt service routine that we're using, CCR0. I left these two in here because I modified a program real quick tonight to do this. So I left these in here because it's just a little extra information. It won't hurt. This timer 0 CCR1 to 2 is the interrupt service routine for the rest of the capture compare registers, and this is kind of a good clean way to lay it out. And then for the push button, this is the interrupt service routine kind of shell. There's no code in any of these, but this is the framework you want to use. If you wanted to push a button and do something, you do it in this interrupt service routine. So this is kind of how you write it up. So back to the one we're actually using though, CCR0. Here all we do is toggle all of these bits that we set as outputs above. So we toggle launchpad LED 1 and 2, we toggle LEDs on my PowerFet booster pack D2 to D5, and we toggle the PowerFet outputs J5 and J6. And we append our value, our count value. Again, remember, continuous mode means you got to append a value to this every time, because think about it, the timer is going to count from 0 to 5,000. When it gets to 5,000, it's going to interrupt, execute all this, and then it's going to continue counting from 5,000 up to FFFF 65,000 something or other. And so you want it to interrupt at 10,000 and 15,000, so make sure you append your count value here every time. Or you can just put the timer in up mode and you'll only count to 5,000 every time. But yeah, it doesn't really matter which one you use. Clear the flag and you're done. So that's pretty much it. It's pretty simple. I just figured I'd put this up here. Maybe some people would find it useful, and this is what this in combination with some of the other stuff. I think there's a video on the tech blog about pulse width modulation to check the pulse width capabilities of these boards, but this is just to exercise all the I/O, make sure everything's working. And so next we'll check it out on the oscilloscope and we'll see the board blinking away. Alright, so I just wanted to show you real quick that this thing is working like we think it is. So if I check the 12 volt output from my 12 volt supply that's connected, you can see if you can see the cursors, they're set at 40 milliseconds, so we're right on there. And the other output is about 40 milliseconds as well. So the fed outputs are working fine. You can look at the board and it's blinking, so that's good. And then if we check the LED pins, you can see that also is rectangular wave at about 40 milliseconds. So looks like this is working fine. This is the code running on the booster pack, and we're just probing around with a oscilloscope probe. So hope that this makes sense. Maybe help some people get started. And if you're interested in this booster pack, this will be up on the website under products. It comes as a kit, and so I'll have another video about this as well, and some more media on that page. So go check it out if you're interested. Appreciate you looking at the blog. Feel free to comment, contact me if you got any questions or comments.